3 times 1 is 3, add it, 9. 3 times 9 is 27, add it is what? 19. 19 times 3 is 50. This is going poorly. This ain't going to work. Someone give me the wrong thing. Is it x equals 3 is 5?
It's 21. Negative 6 plus 20.
Wow.
Yeah.
I'll be here all week. Don't worry. 21. Whoa. That was aggressively bad. Okay, and then 63, then we added is? I don't trust myself at this point. I was like, 8. That's not possible either. 18. 18 times 3 is? Woo! So the problem lied in my mathematics. Say hi, Mrs. Atkinson. So, what do we do now? We type this into our calculator as an x cubed. And we get 1, 9, 21, 18. We would get x cubed plus 9x squared plus 21x because we took an x out, right? Plus 18. Okay, cool. What do I have now? X equals 3 again?
Oh, wait, no.
I'm like, something is wrong. Which will still work out the same. Exactly. That totally has that. Okay, negative 6, add 3, negative 8, negative 6 and 3 is negative 18. Added is 3. I heard sing. What is that?
That was me trying to say 6 and then realizing it was wrong.
It was 3? Okay, so guys, I talked to you about this. Factoring and solving, totally different, correct? So if I ask you to factor, or I ask for the factors, you would tell me they are x minus 3, x plus 6, x squared plus 3x plus 3. That is messy and I don't like it, but I'm not going to. So I will get through this curriculum. This polynomial is my priority. We're done. All right. Yeah? Okay. Factors. Boom. Done. Woo. We have a linear. We have a linear. We have a quadratic. We only have 2 x-intercepts on this graph. So what am I expecting? That works. That works. That fails. So remember, you can type them into your calculator into y1 or y2 and see if it works. Okay. So here we get x minus 3 equals 0. X plus 6 equals 0. X squared plus 3x plus 3 equals 0. X equals 3. X equals negative 6. That's an x-intercept. That's an x-intercept. And then this one I have to go A, B, C. If only 2 are working, if only 2 of them are working, what am I going to expect that this is what's going to happen when I put this in the quadratic formula? It's not going to work. I'm going to get a negative under my square root. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x equals negative 3 plus or minus 9 minus 12 is negative 3 over 2. Now, do I panic? No, I don't panic because I'm expecting to have only 2 x-intercepts. When I see the negative 3 under the square root, I'm actually happy because it is reaffirming what I know, that there's an x-intercept at 3, there's an x-intercept at negative 6, and that's it. I can't have any more. If this wasn't negative under here, I would be panicking because you can't take the square root of a negative number. So guys, listening. Extraneous means I got a solution, she don't work, right? You just circle, cross it off. If I put it into left side, put it into right side, I don't get left side equals right side. Yes, that's extraneous. I got a solution, it doesn't work. Where does no solution come into account? When I can't get a solution. So this is a huge no solution spot. Negative root square root of negative 3. Can I do that? Can I get an answer and it doesn't work? Or could I just not get an answer? Just couldn't get an answer. So this results in no solution. So when I solve, my answer is x equals 3 comma negative 6. Done. Factor looks like that, solve looks like this. They're very different. Okay? Yeah? All right. So, What have we done currently? I have given you an equation. I've asked you for the remainders. You plugged into x, you solved for your y. Input, given, output. Yeah? I've asked you if something is a factor. You put it in, see if you get a remainder of 0. It is a factor. If you don't get a remainder of 0, it's not a factor. I've asked you to factor. So we learned how to do synthetic division so we could factor. Sometimes we get quadratic factors. If we can't factor the quadratic, it just stays that way. Right? That's the best thing ever. If I ask you to solve and you can't factor that quadratic, you have to go to quadratic formula. So solve is that extra step. So whenever I get a quadratic that doesn't factor and they ask me to solve, I'm like, boo. But if they ask me to factor and I get a quadratic factor that can't factor, I'm like, hey, because I'm done. Right? So quadratic factor that doesn't factor when you're asked to factor, yeah, it's a quadratic factor. I'm done. Life is easy. If I ask you to solve, you have to go to quadratic formula. Boo, we don't want to do that. I really appreciate the quadratic formula. Makes my heart sing. But not always, people. So I get it. I get it. Okay? So, what are we going to do next? We are going to talk about how to come up with the equation of a graph. So I've always given you the equation, ask for stuff, correct? Now I'm going to give you stuff for the graph and ask for the equation. This lesson, everyone forgets and writes, I'm sorry, Mrs. Lepp, on it. Easiest lessons ever, forgotten. Also forgotten in grade 11 when your teacher asks you to determine the equation of a quadratic. Those ones are also left blank when I used to get to teach it. I'd be like, they're easy. Okay? So, we're going to talk about a little bit of something first. So, how to, given a graph of a polynomial function of degree n, because it could be up to degree 5, right? I'm not allowed to actually ask anything higher than that. Identify the zeros and their multiplicities. So we're trying to figure out what the zeros are, the x-intercepts, the roots, okay? And their multiplicities. So just because it goes through once, that means it would have a multiplicity of 1. But in order for your graph to bounce, it has to have over a multiplicity of 1 on that x-intercept. So here it says, if the graph crosses the, I would highlight this, if the graph crosses the x-axis and appears almost linear at the x-intercept, it is a single zero. So for example, look at this. This goes straight through, goes straight through. These are zeros of multiplicity 1. You don't have to write multiplicity 1 if it happens once. So in the previous example, we had x equals 6 and negative 3. 3 and negative 6. I don't remember which way it was. 3 and negative 6. These would both be multiplicity 1 because they go straight through. So that's why I didn't have to write anything. Okay? If, number 2, if the graph touches the x-axis and bounces off of the x-axis, it is a 0 with even multiplicity. So if you look here, this, it's a point of tangency. I would star that, highlight that. Everyone forgets about that word. Point of tangency means it bounces. So it hits one x-intercept, and then it bounces it and sends it back up. Do you see that? So it has to have at least 2 x-intercepts there. 1, 2, because it bounces it back up. It could have a multiplicity of 4, 6, 8, etc. Okay, everyone grab their calculators. I'm going to show you the difference. So we're going to be typing these in so we can look at them. My computer still bans me from my calculator, so I don't get to do it. But you're going to look at y equals x plus 1, and then x minus 3 squared. So type that in. So I basically have 1 0 at -1 and 2 zeros at 3. So I'm expecting a point of tangency at 3. And this is a cubic function, because when I expand it out, I get an x cubed.
What did you type? What did you? Oh.
So when you look at it, what is it doing when x equals 3? Bouncing, correct? The point of tangency there, because there are 2 of them. Keep that in your y equals. Don't change your y1. This is your y1. Let's look at y2. What if I made it be a 4 instead? And then I make this thicker if I don't have colored calculators. It could be a 4 instead.
Oh, wait.
X minus 3 to the 4.
Yeah.
Yeah.
Oh, jeez. So what is it doing?
Does it look very similar to the previous one? At the x-axis?
Yes.
Yes. Now our y-intercept is increasing because I have just made that be negative 3 times negative 3 times negative 3 times negative 3 times 1 to get a y-intercept because I have to put a 0 in for x. So my y-intercept can be substantially larger. But my x-intercept, same thing's happening, except at the 3, what's happening? It's a bit wider. Correct? Because what is actually happening is it's going like this. It's going, and it's hitting it once, then it's bouncing it up twice, then 3, then 4, and sending it up. So it's a bit wider down here because it's bouncing 4 times. Correct? When it's a 2, it's bouncing twice. Then it's coming way up here, and then it's coming back down through there. That is not accurate. If you draw a graph like that, you have a test, you get nothing. But you would need more points, correct? I'm just trying to make you visualize it. So take out of y2, take that out of y2. And now, with your thicker line, make your y2 equal x plus 1 times x minus 3 to the 8. We're still going to get a point of tangency because now we have a multiplicity of 8. And remember, we have even multiplicities, we get a point of tangency. But what happens when we have an 8? Yeah, it's because now it's going bounce, 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 8 times. Correct? So it has to take up more space on that x-axis. So you see, it still makes a tangency, it just makes it a wider tangent. Like so, it hits the x-intercept, and then it tries to send it back up. But then there's another x-intercept, then it tries to send it back up, and there's another x-intercept, because there's a whole bunch of x-intercepts there. When there's only 2, it hits this and it keeps going through it. Correct? Pretend that's at 1. It goes through because there's only 1 there. Yeah? But then it hits a maximum at some point and it comes down and it wants to send it through, but then there's a second one there. So instead of sending it through, it hits that x-axis and it actually sends it back up because there's 2 x-intercepts there. So it hits the x-axis, sends it back up. When there's 8, it hits it once, twice, 3, 4, 5, 6, 7, 8. And then sends it back up. So it's going to get wider down here because it's doing more bouncing. It's literally bouncing, but it's just staying there because it's just x-intercepts for a while. The largest I could give you on this one is this one. Because I'm only allowed to max out at an x5 graph. Correct? Quintic, I told you that. So this would be an x to the 1. This would be x to the 4. So I'd have x plus 1, x plus minus 3, x minus 3, x minus 3, x minus 3. And I would have to expand that all out. X times x times x times x times x is an x to the 5. So at max, if I'm going to try and give you a multiplicity, it's going to have to be a 4. Right? Okay. So that's even multiplicities. Then it says, if the graph crosses the x-axis at a 0, it is a 0 with odd multiplicity. So if it crosses through and doesn't bounce, it's odd, no matter what. The sum of the multiplicities is degree n. So this one goes straight through, multiplicity 1. This one goes tangent, so it hits it and then it bounces back up, it's multiplicity 2, 4, 6, 8. If it has this point of inflection occurring, it's going to hit it, and then it's going to hit it again and try and bounce it back down. That's where you get this curve. Do you see that? It tries to bounce it back down like tangency would. But then there's a third one, so it actually sends it back up. So you get this point of inflection. So like it does, if it goes straight through, that's multiplicity 1. If it hits it and kind of bounces it back down, that means it's trying to bounce it back down like tangency would. But then there's a third one, so it sends it through. What do you expect if this isn't 3? What do you expect if that's a 5? It's just going to be wider through it. Because it's going to bounce 1, 2, 3, 4, 5 and send it up, right? If it was like extremely large, it would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then send it up. So this is just wider through here. See that? Point of tangent, or 0 is multiplicity 3, 5, 7, 9, etc. Get you a point of inflection. I can't give that big of a multiplicity because I'm only allowed to get you up to 5, right? So point of inflection will either be 3, or it would have to be 5, but that would be the only thing I could have, like x minus 3 to the 5. That's it. Because I'm not allowed to be anything bigger than a degree of 5. Okay? And then the sum of the multiplicities is the degree. So if you add up all the multiplicities, you should get the degree. So like this one, this would have multiplicity 1, this would have multiplicity 4, that's a degree 5. This would have multiplicity 1, this would have multiplicity 2, that's a degree 3. Yeah? Cubic function. All right. We're going to talk about the end behavior. So, even degree, which means you have a positive leading coefficient or a negative leading coefficient. Even degrees are like x squared or x4 graphs. So an even degree graph would be like a y equals x squared or a y equals x to the 4. This is a quadratic. We did this last year. That is not spelled right. And a quartic. Odd degrees, we have linear, which is like y equals x in grade 10, right? Then we have cubic, which is like y equals x cubed. And we have quintic, which is y equals x to the 5. So you can't go higher than that, but there are more, right? There's an indefinite amount of, an infinite amount, I should say, of degrees. We just maxed out at 5 in the curriculum. You could keep going. Infinite would be infinite, so it would be actually to infinity. Yeah. Okay, our end behavior is based off of the leading coefficient and the right arm. The leading coefficient is what leads the equation. So what would that mean? That would be like if I gave you y equals plus 2x squared. This would be plus 3x plus 6, let's say. This would be the leading coefficient. It's the one that leads it. It's the one in front of the largest exponent. We were taught last year, right? It's the one that leads the equation. Yeah? For odd or even degree, I'm going to write this as a little starred note here. If the leading coefficient is positive, this is for any degree, the graph ends up on right. What do you suspect if the leading coefficient is negative? If the leading coefficient is negative, it ends down on right. So the leading coefficient gives you the end behavior on the right-hand side of the graph. Whether it's odd or even, the right-hand side is how it ends with the leading coefficient. Okay? This sounds like crazy. Within like 5 minutes, you'll all be like, oh, that's really easy. So, I haven't taught you anything. So if you're lost right now, you should be. You have literally just been written down 2 sentences. Okay? All right. So, even degree, to help you out, a quadratic could look like this. We've seen quadratics, correct? Symmetrical, nice little looking U or an upside down U. We did a whole bunch of those last year, yeah? Quartic often look like W's or M's. This one ends up on the right. Do you see how the W ends up on the right? This would be positive. This one ends down on the right. It would be a negative leading coefficient. Yeah? Okay, let's look at linears. Linears we did in grade 10. This one is a straight line. It ends up on the right. So what do you think the leading coefficient is? Positive. Okay, cubics make it you're looking a little like S, but they're symmetrical too. What would this one end up being? What leading coefficient? positive because it's up on the right, correct? Quintic has like an extra little bump in it. What would the leading coefficient of this one be? Negative because it's down on the right. Do you notice that the even degrees are like, woo, cheering, or like, ah, not good? Eh? So like even degrees are like quadratics, are like both yay, or both blah, or quartics are like yay, blah, 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 in the middle. Yeah? Yeah. That's even degrees. Even degrees are like, yeah, score, yeah, tough, you know, something like that. But odd degrees are a little more fun, I would say, because they disco. They either disco straight up, and they're like, I just do this. Maybe linear. I disco weirdly. Or you could be cubic and you can be like, I disco. Or you can be like Quintic and you're like, I really like to disco. But you disco nonetheless. Okay? And you're like, yeah, in the day you probably discoed. No, that's the 70s. I wasn't born. Don't even go there. Okay, children? You're thinking it. I don't want to hear you thinking it. I don't even know what this is. I've only seen it in movies. So have you. We're in the same boat. I did not live in that era. Do not judge me. I was really close though. I was 83. But it's fine. I was not. Therefore, I am not a 70s child. Probably was good times, but I wasn't. I was an 80s kid. 80s kid's so fun. You have no idea. Your parents really didn't, like, unless you didn't come home like 3 days later, they weren't that concerned. They're probably like, oh, they're probably out, like, still mowing the lawn, or probably still bailing. Yeah. Get out there and bail longer. Why are you home? The sun is out, don't care, turn on the lights. That's what they would say. Nonetheless, I worked a lot as a child. So, positive leading coefficient ends up on the right. Do you see that? And because it's an even degree, it goes, and it's the same direction. Yeah? So the even or odd degree tells you how it ends on the left. The right is the leading coefficient, doesn't change whether it's odd degree or even degree. So this ends up on the right because it's a positive leading coefficient. And because it's an even degree, it ends up on the left. Yeah? This one's a negative leading coefficient, so it ends down on the right. And because it is, it ends down on the left. These are always awesome because their domain and range, well, their domain is XER, negative infinity, positive infinity. It's going on for life. Boom, boom, boom. Going on for life. Boom, boom, boom. They have like a in the middle, but still going on for life. Yeah? But if it's concave up or a positive leading coefficient, it's going to be greater than or equal to your minimum. So like if it was like this, we'd have to find this bad boy, and then it would be greater than or equal to it for range. Yeah? But if it was concave down, so even like this, we'd find this bad boy. We'd find the maximum using second trace math. And we'd say it's less, the whole graph is less than or equal to that very high point. Correct? Because the graph, that would be the absolute highest it could go, and then it's less than it. We need to understand domain and range. If we're memorizing, it lends itself to bad things on a diploma, because you've seen the domain and range type questions on the diploma. They're not easy. Okay? You will like it by the end. You will. Can we take a bet? Okay. The maximum or the minimum number of x-intercepts that it could have would be 0. Correct? Even degrees? Because even degrees go in the same area, right? They both end up or they both end down. So they could have no x-intercepts because it could go like this or it could go like this. Correct? Because the arrows don't disco, you could have no x-intercepts with an even degree. It could be completely above or it could be completely below. We agree with that statement? And it's because the arrows go in the same direction. Yeah? You could also have any variance in between that. So for even degrees, the lowest you could have is 0, and the highest you can have is the degree. And then you can have every variance in between. So if I did a degree 4, I could have 0, or I could have 1. That would be a lie. That is going to give me 2. You're welcome. That could 2. Or I could have 1 with a multiplicity 2, but still only one x-intercept. Or I could have 3. One, 2, 3. This one just happens to have a multiplicity 3. Or I could just go meow, 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 meow. 4. Yeah? So once you have the minimum degree and the maximum degree, minimum number of x-intercepts and maximum number of x-intercepts, you can get anything in between. So even degrees, because their arms go up or go down, have 0. And then if it's a degree 2, it would have 0, 1, 2. If it's a degree 4, it would have 0, 1, 2, 3, 4. So let's see if the maximum is equal to the degree, the minimum is equal to if it's even or odd. Odd degree functions disco. So at some point in time, they're going to have to cross through, correct? So what's the minimum number of x-intercepts an odd degree could have? 1. And then the maximum, once again, is the degree. So if it's linear, it's going to have 1 minimum or 1 maximum. If it's degree 3, it's going to have 1 minimum, 3 maximum, and then it can also have 2 because it can have anything in between. If it's a degree 5, it can have 1 minimum, 5 maximum, and then 1, 2, 3, 4, 5. Right? So you have your min, your max, and then any variance in between. Okay? You will learn to love discoing. Discoing, unless it's a word problem, is XER, YER. It goes out for life this way, right to left. It goes out for life, up and down. Okay? The domain and range of linear, quadratic, cubic, and quintic are the best because they literally disco. So they go out, right, and left for life. They go out, up, and down for life. So their domain and range is negative infinity, positive infinity in integral notation. This one has our odd degree as a positive. The leading coefficient ends up on the right, but it has to disco, so it ends down on the left. Yeah? This one has a negative leading coefficient, so it's down on the right, but because it discos, it has to be up on the left. Yeah? Kind of making a little more sense about that leading coefficient ending on the right. The degree tells you how it ends on the left. Okay. And then all the information in between. Okay. Let's go through these. What is the least possible degree of A? First off, is it even or odd degree? Why? Disco. Truly doing its disco. Yeah? So we know it's odd. I'm going to help myself out. We know it's odd. Our odd options for degree are 1, 3, and 5. Those are our options. We don't get other ones. That's stop 5. Is it a degree 1? No. Because what? There's a bend in this graph, correct? Linears are just straight old graphs. Is it degree 3? Well, let's count. What is the multiplicity of this x-intercept? What's the multiplicity of this x-intercept where it goes straight through? 1, correct? What's the multiplicity of this one? 2. Do you see how I say least possible degree? I would say least possible degree because it could be 2, it could be 4, it could be 6, it could be 8, it could be 10, it could be 12, correct? But when it says least possible, what is the most of that multiplicity could that one be? 2. You have to pick the lowest multiplicity it could be when it says least degree. So I have a multiplicity 1 and a multiplicity 2. How many does that add up to? 3. So what's the least possible degree? Degree 3. Also, it makes that nice little S curve, correct? Which is a cubic function. What is the sign of the leading coefficient? Positive or negative, and how do we know? Tell?
Negative because it's ending in the bottom right.
Yes. We don't care what the degree is for the leading coefficient. We care how it ends on the right. So this ends down on the right, so it's a negative leading coefficient. The x-intercept with the least possible degree. So I'm going to say the x-intercept is going to be x equals negative 4. Multiplicity 1. Do I have to write multiplicity 1? No. It's the only one you don't have to write. And then this one, x equals 1. Multiplicity 2. And then I'm going to star this because literally the equation is the easiest thing to find and you guys all don't. And you might be like, Mrs. Lepp, that's really aggressive saying you all don't. Because no one ever answers the equation on the test. They just write, sorry, I know you starred this. I don't know how. You do you. It's your notes. Don't even put any. Be a rebel. Okay.
I put a star.
Okay.
It
We'll look
gives
great.
a couple more stars to be.
Thank you.
Oh, and already even
I agree. I support that star add addition. All right. Everyone listening? So we worked from that plain old equation, right? We were given a plain old equation, and then we got the factored form of it. That's what we did in the previous days. Yes? Plain old equation, your standard form, and we worked it, that general form, and we worked it into factored form. Yes? Then that factored form, we set equal to 0, and we worked to solving for the x-intercepts. Correct? So, what we did in the last few days is we worked from standard form to factored form to set equal to 0, get my x-intercepts. How would we get the equation of the graph? Take my x-intercepts, work back to factors, go back to factored form, get my y equals. Yes? Okay, so let's talk about that. All right. Side note, caveat. Y equals x plus 2 times x minus 3 squared. Type that into your calculator. Bless you. I feel that in my soul. That's how I sneeze too. Kindred spirits. Basically my spirit animal sneezer. That's what you are. Try and sneeze quietly, but then my head almost explodes. I can't do it. Yeah. I tried. It just doesn't work. Does everyone have that in? Okay. We have an x-intercept at -2 and one at 3, multiplicity 2. True statement? Okay. I made these really large numbers. Can you change this one out to a 1 just so we're not going to have, trust me, it makes you not have to make your screen so big. Change that out to a 1. So we have an x-intercept at -2 and an x-intercept at 1, multiplicity 2. We agree? What is my y-intercept at currently on that calculator? Pardon? It's at +2. Yes? And the maximum's at a certain spot and the minimum's at a certain spot. We agree? What if I add a leading coefficient? If I add a number in front, is what I should say. A vertical stretch. What do vertical stretches change? Y values, yes? So will my x-intercept change at all if I put a number in front? But will it change my y-intercept? Will it change my max and mins? Yeah, it'll change every other point but those x-intercepts. Now what happens is people will give me this as their equation always. But you have to actually make it conform to whatever the heck the y-intercept is. So what if my y-intercept on the graph I gave you, and I made you come up with the equation of it, what if the y-intercept, currently it's a 2, right? On your screen it's a 2. What if the y-intercept wasn't a 2? What if the y-intercept was actually a 4? What's my a going to be? What's this value in front going to be? 2. Type that in. That leading, well, not leading coefficient, that numerical value in front, that vertical stretch changes depending on what the y-intercept is, depending on what the max and mins are. So you actually have to find out what the heck that a value is. Because if you actually don't believe me, the x-intercept stays the same every single time, correct? If I change that number in front, if I change it to a half, my x-intercepts are going to stay the same, my y-intercept is going to shrink, and my max and mins are going to shrink, right? Because it changes every y value except for the x-intercept, because what's on the x-intercept for y's? 0. And when you vertically stretch, you multiply. When you multiply zeros by anything, they stay the same. Okay, let's keep that in our back pocket when we go do this equation. So when I go to do this equation, I'm going to go y equals, and I'm going to leave a little space here and talk about that in a second. I need to put my x-intercept. So I have x equals -4. What would that be as a factor? Because I need to work my way. X plus 4. As a root or a 0 or an x-intercept, the only way I can describe x equals -1 as having 2 x-intercepts there is to say multiplicity 2. We agree? How do I show that as a factor? X minus 1 squared. And a lot of people forget the squared. Now, sometimes I don't have a vertical stretch on the graph. It is good like this. Sometimes I do. So your first step always is to find out the factored form and put in an M, N, A. A lot of people put an A here, but then the way they ask the questions on the diploma, it messes you up because you're like, A is this. Your A isn't the same as their A, so I stopped using A. So I'm going to use M, because M isn't used very often. I'm letting M be my vertical stretch factor, okay? I need to find out if there is one, or if it's just a 1. If I need to solve for M in this equation, in any equation, if I need one variable out of that equation to solve for, what do I have to do? You need to know the other what? The other 2 variables, correct? Like in physics, when you go to do physics, and they give you an equation, and they want you to solve for the heat capacity or something like that. Chem, welcome to my math, because I don't know chemistry. That's in heat capacity. Oh, specific heat capacity is in chem in science 10. Oh, dude, it just keeps going through? That's lovely. Let's think about, potential energy. That's in physics.
And chem. All of the above. It's in both.
It literally doesn't leave, it just stays
And
in
in
both.
bio, actually, too.
Oh, wow. Kinetic energy and potential energy is in bio and physics and chem?
Yes.
Well, you should know it. Anyways, isn't it like EK and EP?
Yeah.
I still remember some things. It's not where they found, but whatever. So if you need to find that, you need to fill in everything else, correct? Any formula you're given, you have to be able to. Force, the force formula. That is in physics.
That is in physics.
Yes, I hit 1. Okay. If you need to solve for force, which is often by itself, that would be the stupidest thing for you to solve for. But whatever, doesn't matter. It's irrelevant. You need to know the other fill-ins, correct? So, if I need to solve for M, which I circled really far around here by the time of physics biochem, it's fine. It's fine. If I need to find M, I need to know everything else. Yes? What are the other variables? X and Y. Where can I get an X and a Y to fill in? You don't want to use your x-intercepts because your y would be 0 and they'll all cancel off. Any other point besides the x-intercepts. On a diploma and on a unit exam, there's often a bolded point on a graph. They're not bolding it for fun, like, oh, it's one bolded point. I just really like this point. It's often bolded because they're saying, here's this point somewhere in the equation. So, if this was a diploma, often it would look like this, and then this would be bolded. What does that scream? Use me. That's what it screams. What is the coordinate of that? Please tell me you know the coordinate. 0 and -4. Ooh. Thought you couldn't find a coordinate for a second there. I was a little scared. Scared, as some would say. 0. Brain halted. -4. Couldn't remember if it was negative or positive. So that's my x. That's my y. I can plug them in and solve for m. So I'm going to get -4 equals m. 0 plus 4. 0 minus 1 squared. These are all multiplied, so I'm going to get -4 equals m. And then this is going to be 4 times 1. We agree? Divide by 4. M equals -1. So now I have y equals -1, x plus 4, x minus 1 squared. This makes sense. It's negative, and it's down on the right. So I know my m's probably going to have to be a negative, right, to get it to end down. But do you see how I have to solve for that m? If you forget about it, you're going to give me the equation x plus 4, x minus 1 squared. And I really hope you at least know you're wrong. Like, I hope that when you hand it to me on the test, you know, oh, crap, I'm not getting full marks. Why should you know, oh, crap, I'm not getting full marks if you don't solve for m? You have a graph in front of your face. You have a supposed equation that should be that graph. What could you do? Put the equation into your calculator. Change your window to be the window of the graph that I gave you. Now, sometimes your window is horizontal and their window is vertical, and so it's not going to be perfect. But you can check the max, mins, y-intercepts. It should be the same graph. If it's not, you made an oopsie. So at the very least, you should know you're wrong and not getting full marks. I hope that you then know you're wrong and be like, what am I missing? Oh, the leading coefficient at the end. Okay? All right. Try this one. Fill it in. What is the least possible degree of this graph? 4. Now, guys, remember, the curriculum is awesome in a certain way, and the fact that it limits me, correct? I can only give you up to degree 5. When it's even, we're, right? Whatever, I don't care. Arms are in the same direction, yeah? So it's either degree 2 or degree 4. I hope that because a third of last year's curriculum was quadratics, you realize that that is not a quadratic. That is not a parabola. That is not degree 2. Therefore, it must be what? Degree 4. Could it be degree 6? I'm not allowed to ask you anything higher than degree 5. Okay? Degree 3 and 5, I can see a little mix up there. I can get that. But on the even degrees, it should be easy. Is it a quadratic from last year? Nah, it's 4. Okay? So, degree 4. 4. What's the sign of the leading coefficient? Positive or negative, and why? It's positive. Why? It's up, up. Degree 2s and 4s are kind of awesome. Even if you forget it's the right side, the left side's the same, right? However, it is dependent on the right, and the left side's the same because it's an even degree. So, and it's positive. And then I help myself out by saying up on right. Okay, what are my x-intercepts? I have x equals 4, and then I have this little curvy curve through here. So this is x equals 4, and then this is x equals 3 multiplicity 3, because it can't be multiplicity 1. It does a little swoop-to-swoop. It can't be multiplicity 5, because 5 plus 1 is 6, and I'm allowed to max out at 5, and in this case, 4. Yeah. Okay, so we have x equals 4, negative 4, sorry. And x equals 3, that does not look like an x, looks like an alpha, but you can deal. Multiplicity 3. So then we go y equals m. X plus 4. We work our way backwards to our factors. X minus 3 cubed. Then we need a coordinate to solve for m. I'm going to use, I don't know what. I'm a rebel without it. What? That one? That one. That one? Sure, that one. That one? They're going to end up the same. All right.
They don't end up the same.
They should end up the same.
No, they don't.
Okay. On a diploma, if they don't end up the same, that means one of them doesn't actually go through. Correct? Because I didn't give you a bolded point, I would accept either of yours because that's my fault, not me. On a test, though, I'll give you a bolded point. If you then choose to go a different route, pick something else random, I don't know why. If it doesn't come out the same, bad on you, right? This one I didn't give you a bolded point, so I get it if you chose one or you chose the other. Cool. As long as your mathematics is correct, I'll take it. I'm going to use 1 and negative 1. So, xy. Negative 4 equals m. 1 plus 4. 1 minus 3 cubed. Negative 4 equals m times 5. And then negative 2 cubed is negative 8. Negative 4 equals negative 40m. Divided by negative 40. N equals 1 over 10. And then a lot of people do this. Wow, that's a really crappy equation. Do you know what m equals 1 over 10 is? I don't know if that's x or y. It would be like at 1/10 I'd have a horizontal line, or 1/10 I'd have a... So don't box m. You need an equation. Okay. I have this really awesome worksheet with a blank piece of paper on the back, super prepared. You're welcome.